Hello all, welcome to 7th session on data science. In this particular session, we are going to cover Python Pandas. So first, before going to start, we are going to see first objectives of today's session. So first objective is we are first going to see introduction to the Pandas library. Then we are going to see data structures that are offered by your Pandas. So there are two important data structures that you need to remember. First is series, second is data frame. Then third, we are going to see how to read data with Pandas. Then you are going to see some data manipulation techniques. First of all, you are going to see how to select data. Then you are going to see how to filter a data and how to sort a data. Then you are going to see grouping and aggregation. And lastly, you are going to see merging and joining of the data. So let's get started. So Pandas is a very popular Python library. So this particular Python library is given to you for data manipulation. So data manipulation means any kind of data that you have, Python has libraries in order to handle that particular data. Along with the data manipulation, Pandas can also help you with the data analysis. That means visual representation of the data can also be provided with the help of Pandas and some integration with another libraries. So this particular Pandas library is first of all, it is very high performance. Second thing, this particular library is very easy, provides you with very easy to use data structures. So series and data frames are the data structures that are provided to you. So they are very fairly easy to use. Along with this particular data structures, you will also be provided with the tools and functions in order to handle this particular data. So the data that we handle using your Pandas is nothing but the structured data. So now how to import. So this particular thing is a library. So in order to use that library, first we have to import library. So import Pandas as PD. So PD is nothing but your alias. Instead of using complete library name, we are going to use alias name PD. Now these are the key features of your Python. So first thing that you can do with your Pandas is data cleaning and preparation. So if you have missing data in your data source or in your file, let's say. So if you want to handle your missing data, then there are multiple things that you can do with the help of Pandas. Okay, you can fill that missing data with particular value, or you want to have a certain value to put in that particular missing data, so that can be done. You can also reshape your data with Pandas. And third thing, you can also perform data normalization. Now next part is data analysis. So data analysis means the last part of the objectives, that is aggregation and grouping, and lastly merging and joining. This all comes under your analysis part. So grouping, aggregation, these are very powerful summarization tools. Okay, so whenever you perform some grouping and aggregation, you get very useful insight about your data. Okay, lastly data visualization. So data visualization, you can integrate with another libraries, for example matplotlib, cburn, in order to create a plot or visualizations. So sometimes it is very hard to visualize the data. So if you can plot that particular data, it becomes very easy to understand the data as well. So in order to plot the data, you have libraries available called matplotlib and cburn. So using these particular libraries, you can plot and visualize the data. Now common use cases. So common use cases, again, this particular library can be used for data exploration. That means you can use the data frame in order to load the data, and then you can extract insights from that particular data. Then you can handle your missing data. You can also handle duplicate entries and any other inconsistencies that you can find in the data can be handled by your Python. Then you can perform data manipulation operation like filtering, sorting, transformation of the data. Then you can perform data analysis, that just now we have seen data analysis and visualization. Both the things are available with the help of Pandas. Now integration with another libraries. So Panda integration integrates well with another Python libraries. So which Python libraries? So NumPy that we have seen in the earlier session, then matplotlib and then scikit-learn. So scikit-learn is particularly that this particular library is important for your machine learning purpose, and matplotlib is used for your plotting of the data. Okay, so pandas can be integrated with this particular libraries. It also supports data import and export from various formats of data. So various formats like CSV, Excel, SQL database, JSON, any kind of file that you have, Pandas has functions that are available to you in order to read from these particular files. Now we are going to see very important part of Pandas is data structures. This particular part is very important. So first data structure that we are going to see is Pandas series, and another data structure that we are going to see is Pandas data frame. So now Pandas series. So Pandas series is nothing but an array capable of holding any type of data. Okay, so it's an array capable of holding any type of data. So it consists of two parts. First of all, you have data itself, and then you have indexing. So here you can say pandas can be created with the help of your list, arrays and dictionaries or scalar values. So we are going to currently create a pandas series using list. Okay, so this is my list. So how can you say this particular thing is a list? So wherever elements are enclosed in a square brackets separated by comma, then that particular representation is called as the list representation. So this particular representation is list, and we are going to provide some index. So let's say how this is going. So here we will say series 1. So the first step that you are going to do is import pandas as PD. Okay, then you will see series 1 equal to, now if you want to create a series, you have a function called as pd dot series. Okay, this particular function is given by your pandas. In that we can create a series using your list. Okay, so using your list, arrays, dictionaries, anything we can create it. So we are just now we are going to see it with list 20, 30, 40 and 50. Okay, and let's say indexes are A, comma B, comma C, comma D, comma E. Okay, if I say now print series 1, then let's say what we are getting. So this particular thing is nothing but one dimensional array. So one dimensional array means you can have data itself and its indexes. So my data is 10, 20, 30, 40, 50, 50, 50, and my indexes are A, B, C, D, E. Okay. Now let's say we are having now series 2, and instead of, if you are given the indexes, these indexes will be If you are giving indexes, then your indexes will be used. If you are not giving any indexes, so let's see what happens if you are not giving any indexes. So if you are not giving any indexes, by default indexing will be used. So by default indexing means we have zero based indexing. So zero based indexing means first element will be located at 0, then second will be at 1, 2, 3, 4. So this kind of thing is available in your series. Okay, just as we have seen in the list and tuple, this kind of indexing is all the same kind of indexing is available with your series. Let's say now I want to extract first item from the series. So I will say series to 0. So yes, it will be this. Then if I say series of 3, that means series 2 of 3, that means 0, 1, 2. Your 40 will be extracted. Okay. So this particular thing is nothing but indexing. Your series also supports slicing. So how does it support slicing? So slicing may you will have series 2 now. This particular thing is series 2. So in that I want to go from 0 to 3. So I will say series 0 to 3. Sorry. Here it will say name error because we are going with series 2. So it will start with your 0, that is 0 is inclusive and 3 is exclusive. By default your step is 1. So what you will what you will have start, stop and step. Okay. So same way it will go from 0, 1 and 2. Because 0 is inclusive, 3 is exclusive, 3 will be excluded, it will print 10, 20, 30. Okay, so this was your Pandas series indexing. So this particular thing has 0 based indexing. Right? So 10, 20, 30, 40 and 50. This is my indexing. So these will be my indexes 0, 1, 2, 3 and 4. Okay. So let's say this particular thing has series 2 as its name. So I will say series of 0 in order to extract first element. And series start, stop and step. This particular thing is available. This is nothing but your slicing. So this particular part is inclusive, this particular part is exclusive, and step is your by default 1. Okay, so this is nothing but your Pandas series. So if you have given the indexes, that those particular indexes will be used. Now we will also see it with your indexing, that is series 1 this particular part has this type of indexing. So we will see how can we retrieve in that particular case. So series, I will say 1 in bracket. Now this particular indexing has string type, so I will say series 1 of A. So it will retrieve your first data. So this is nothing but your data and these are nothing but your indexes. So in order to access the data, you need to work with the indexes. Okay. So let's say series of, I want to go from A to, let's say I want to print ABC's data. So this will be printed A, B, C, D. Okay. So this is how your Pandas series work. So series has different attributes along that are provided to you. So first attribute is index attribute. So index means it gives you the index labels of the series. Okay. Then next is values attribute. So values means it gives you the data values that are available in your series. And third is data type. If you want to see the data type of elements in the series, you will say D type. So let's say how to use this attributes. Let's say now we are considering series 1 only. Okay, let's say series 1 dot index. So yes, these are nothing but your index, this is nothing but your data. So these indexes are provided to you. Then series 1 dot, let's say, values. Now these particular parts are nothing, these are nothing but attributes. So you do not have to provide opening and closing brackets. Opening and closing brackets will be provided in case of functions only. These are attributes. So you do not need to provide it. So these are nothing but the values that are present in your series 1. So 10, 20, 30, 50, 50. Okay. Then you can also check series 1 dot d type. So what kind of data is available in your series? So it's saying it is integer. So it is right. Okay. So this is how you will use index, value and d type. Now let's see the next set. The next set contains now shape. So shape means a tuple representing the shape of the series. Now this particular data structure is 1D. It's a one dimensional data set. So it is going to give it to you 1D. So this is nothing but shape. A shape representing, it is going to give you a shape, a tuple representing the shape of the series. So shape of the series means currently this particular series has 5 elements. So that's why it is going to give you the shape as 5 comma. Okay, do you understand this? Why is it going to give you like this? Because this particular data structure is 1D data structure. So 1D data structures means it's going to give you the shape something like this, that is 5 comma. That means this particular series has 5 data elements that are available with you. So that's why shape is 5 comma. Then next is nothing but the size. The size. Now size means number of elements present in the data set. So series 1 dot size. So yes, there are 5 elements in that particular series. Okay. Then next particular attribute is empty. If you can check whether your particular series is empty or not. If that particular series is empty, it is going to return true. Okay. True in case of series is empty. False if not empty. Okay. So currently our series 1 has data available with us. So I will say series 1 dot empty. So yes, it is going to give you false. True in case if series is empty. Okay. So next you can also check the index data type. So in order to check the index data type, you have an attribute called index.dtype. Let's say series dot index dot dtype. Series 1 dot index dot dtype. So this particular thing is nothing but the data type's index. Index is data type. Sorry. Now we have some series built-in functions available with us. So there are some functions. For example, we have append, then we have apply, count. If if duplicates are there, you can drop those particular duplicate values. So we'll start with some series built-in methods. So first built-in method is apply. You can apply a function to each element of the series, same as the broadcasting. You can apply each element a function on each element of the series. Okay. So in broadcasting operation, what you were going to do, you had one numpy array. So on numpy array, in that numpy array, you were applying a specified operation on each element of the array. Okay. Then next function is count. So count function is, it contains non-NA or null elements in the series. So let's see first of all what is our series. Our series looks like this. PD.series 10, 20, 30, 40, 50. Then there is one NaN, that is that null value, and so this is my series. Okay. So if I say s1 dot count, so it contains now 0 to 10, that means it contains 11 elements. So count only counts those elements which are non-zero, that means we should have 10 as our count, because this particular fifth is your missing value, or it is called as null value, or this is represented as not a number. So this NaN means this particular data is missing from the series. So count discards this particular data and only counts those who are present in the series. So you have 10 elements that are present. Then if you want to drop this particular null elements, you can use drop any method. Okay. So if you say s drop is equal to s1 dot drop any. So if you do this particular value will be dropped from the series. So here I will say print drop. So let's say it is dropping it or not. So yes, earlier on the fifth location we had a NaN value. Now in the new series we do not have this particular value. Okay, that means drop NA is dropping that particular missing value. Then next part is, now you can drop duplicates also. So if you want to drop duplicates, you have a function called s1 dot drop underscore duplicates. Okay. So if you do this, here many of the values are repeating, so it will drop it. So here we can say print duplicates. So the duplicate, yes, so it is dropping that duplicate value. So from this particular data, if you want to, now I have used S1, so it is using this original data. So original data was containing NaN, so that's why you are seeing this NaN. So if you want to use this particular series, so this particular series name is drop. So if I say drop, so let's say So yes, now we are getting only those values which are unique in the series. Okay. So along with this you can also calculate max, mean, median, minimum and mode. So max means it will return the maximum of the series. Mean means it will return the mean value, that means average of the series. Median means will calculate the median value. Median means it will calculate the middle value of the series. Then mean means it will return the minimum value of the series. And mode means it will return the value that is most repeated in the series. So let's say one by one. So I will say now, I will use this duplicate. Dot, I will say max. So from the look at it, you can say 50 is the max. If I say I want to calculate minimum, so duplicate dot mean. So minimum is 10. Now if you want to calculate average, so duplicate dot mean. So this particular function gives you the average. So this is nothing but the average of these 5 elements. Now I want to see mode. So mode means the value that is most repeating in the data set. For example, mode. And comma 10. So this is nothing but your series. Okay, in this particular series, if you want to calculate mode, so how do you calculate it? So mode means the most repeating value. Most repeating value is now 10. So this particular series mode is 10. Okay, and one more thing, what is median? So for example, I will say median. So median means middle value of the series. So if you have odd number of elements, so you can clearly say 3 is your middle value. But if you have series something like this, so what happens is middle two values are taken out, their average is taken, that is 2.5. This is nothing but your median. Okay, this is how your median is calculated. So let's see now with the help of example. Now a duplicate looks something like this. So instead of drop, I think we'll say drop now. Okay, this is our drop series. Now here we will say drop dot mean. So this particular thing gives us the mean, that is average of this particular numbers. Then dot, we'll say median. So please calculate on your own end whether the calculation that I have shown you, it is similar to that what you are getting. Okay, 0 to 11. Now these values are nothing but 0 to 10. That means we have 11 values available with us. Then So here we have calculated drop dot median as 30 and drop dot mode as 30. So first of all we will see drop dot median. So we have now 10 values available with us: 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 means we have to go to the middle values. So middle two values are these two, like 4 values are up and 4 values are down. So 50 plus 10 is 60 divided by 2, that is 30. So this is nothing but your median. Now whenever I am saying drop dot mode, now please observe. So drop dot mode, it is having its own index. That means this is index and this is nothing but data. So where have you seen this kind of representation? This is like a series representation. So if you want to now extract only 30, so I will say I want only 0th location data. So yes, this will give you the 30 only. Here if you do not give 30, so why is it getting like this? Because there can be more than one modes in the data. So that's why you are having a series. So in the series, if you want only first element, so I will say drop dot mode. This is your series, and from this series I want 0th location data. Okay. So if you find this particular representation a little bit difficult right now, you can do it like this also. Drop dot mode. Okay, so both of the representation will give you the same result. Now you will also have some n unique number functions. So n unique means it returns the number of unique values in the series. Okay, number of unique values, and unique means it returns the unique values in the series. So here we will see now, we'll take the drop only. Instead of drop, I think we will take this duplicate. Okay, so duplicate. Okay, from this we will say duplicate dot n unique. So number of unique values. So number of unique values are currently 5, so it will represent 5. And if you want to see what are those unique values, so you will say duplicate dot unique. So if you want to see those unique values, you will say duplicate dot unique. So you will get the unique values. Same thing, you can do it with the drop also. So drop dot n unique. Here I will say drop. And here I will say drop dot n unique. So how many number of unique values are there? So I will say now there are also I think 5 unique values. Yes, 10, 20, 30, 40, 50. And if you want to say see what are those unique values, so you will say unique, drop dot unique. N unique gives you the number of unique values, and if you want to see what are those unique values, you want to use unique function. Here you can also have one more interesting function, that is value counts. So value counts returns the series containing counts of unique values. So here I will say drop dot value counts, I will say drop dot value counts. So here if I say drop dot value counts, so this is our drop. So here I am getting 30. This particular value is getting repeated 3 times. 10 is getting repeated 2 times. Okay, right? 30 is getting repeated 3 times. 10 is getting repeated 1 and 2. Same 20 is getting repeated 2 times, 50 2 times, and 40 is repeated only getting repeated 1 time. So that is nothing but drop dot value counts. How many unique values are there in your series and what are its counts? So if you want to count that, value counts is your function. Okay, so this was your set built-in methods. Now let's get started with the most important second data structure from your pandas is pandas data frame. So pandas data frame is, it is a two-dimensional labeled data structure resembling table or spreadsheet. So something which has rows and column representation. So that particular thing is called as a pandas data frame. Okay. So if you compare it with the NumPy, you can say it is nothing but the 2D representation. Okay, 2D NumPy array. So 2D NumPy array means it will have number of rows and it will have number of columns. Okay, so this particular data frame can be used for your data manipulation as well as for your data analysis. Here your pandas data frame can have number of rows along with number of columns. Okay, you can have any number of rows and any number of columns. So we are going to now create a data frame. So for creating a data frame, you will need first a data. So this is our data, name, age and city. So this particular, can you tell me what is this particular data structure is? So this particular data structure is nothing but dictionary. So dictionary means it will have keys and it will have values. So we have 3 keys, name, age and city, and we have 3 with respect to their keys, we will have its values. So whenever you pass a dictionary into data frame, your keys will be converted into your columns. Keys will be converted into columns and rows. Values will be converted into the rows. Okay, keys will be converted into the columns and values will be converted into the rows. So let's say how it is getting created. Now we have given 5 names, 5 ages and 5 cities, and what we are doing is pd dot data frame. Now in order to create a series, we had a series named function. In order to create a data frame, we have a data frame named functions. So within this particular thing, we will pass the data that we want to create, and this will create our first data frame. Okay, so let's see how it is we are going to do that. So here I will say data, I will say name, colon, in bracket I will say now Alice, comma, Bob, Charlie, David, Emily. Charlie, David, and this is Emily. Okay, so these are your names. Second thing is we are going to consider age. So we have ages as 25, 30, 35, 25, 25, 30, 35, 40 and 45. Okay, comma. We have now city. New York. LA, Chicago, Houston and Boston. Houston and Boston. Okay, so in order to create a data frame, I will say PD, now df is equal to PD dot data frame, in bracket I will say data. So let's see what is in the df. So yes, this is now your data. Now this has a different representation from your series. This was your series representation. That means, sorry, not this, this one. You will have your indexes and you will have your data. So your data frame was a 2D data structure. So 2D means you have a number of rows and you will have number of columns. So in the data we have passed the dictionary. So in dictionary I have said your keys will be converted into your column names and your data, that is values, will be converted into the columns. See, your Alice A25 New York, then Bob 30 LA, accordingly Charlie 35 Chicago, David 40 Houston and Emily 45 Boston. So this is nothing but your data frame. So if you cross check it, so type, if you say df, so that is nothing but your pandas core dot data frame. So yes, whatever we have created, that is nothing but your data frame only. So please remember this, whenever you are passing dictionary as the data, so your keys will be converted into columns and data will be converted into, values will be converted into rows. So this was your data frame creation. Now next thing, there are number of attributes. The same attributes that were available with your series, the same number of attributes are available with your data frame also. So data frame dot index, if you see now, so here df, this is our data frame. Okay, so here if I say df dot index, so we will get the indexes. So indexes means this index, it will start at 0, it will stop at 4 and your step is 1. Then if I say df dot values, so I will get the values that are present. So values means this is one value, this is second value, this is third value, this is how you will get the values in the data frame. Okay, then you can check the data type as well as shape. So first check df dot dtype. Sheep. Okay, here let's say shape. So shape means how many number of rows are there and how many number of columns are there. So we have 1, 2, 3, 4, 5. So 5 number of rows and we have 3 number of columns, name, age and city. Okay. Then let's check the size of data frame. So size of data frame means df dot size. If I say, so size means how many number of elements are present in the in the data frame. So number of elements means this is different element, these are different elements, these are different elements. This means 5 elements in name, 5 elements in age, 5 elements in city. So in your total 15 elements are there in the data frame. So that's why df dot size is 15. Now if you want to access the columns, so df dot, I will say now age. Okay, if I say df dot age, so this is nothing but your age value 25, 30, 35, 40 and 45. And here if I want to now check the data type of this particular age, then yes, so your data type can be applied on single columns, right? The data type of each column in the data frame you can check. So this is how you will check it. Okay, here you can also check whether your data frame is empty or not. So if it is empty, it will return true if there are no elements in the data frame. But if there are elements in the data frame, it will contain false. Then you will have ndim. Ndim means the number of dimensions of the data frame. So data frame has two dimensions. So that is, one is rows and another is columns. So df dot ndim is 2. So number of rows and number of columns. So that's why ndim will always be, in this particular data frame, it will always be 2. Then you can check index dot data type as well as column dot data type. So this two things you can try it on your own. Same way I have shown it to you, you will do it. Okay. Now there are some functions that are available, built-in functions that are available in your data frame. So first function is transpose. So transpose means it transposes the rows and columns of the data frame. So for example, this is our data frame now. Okay. So here if I say df dot transpose, so transpose means it will convert rows into columns and columns into rows. Okay. So let's see how it will happen. So here I will say now transpose 1. So here Alice, Bob, Charlie, David, Emily, 25, 35. These all rows have been converted into columns. Okay, this is first column, Alice 25, New York, Bob 30, second column. These were your rows, so it has been converted into columns, and these columns has been converted into rows. Same, if you have any NaN values that are present, you can drop it using df dot drop in. It will exactly work as your series value. Okay, here here we'll say this is our data frame. Okay, now my data frame has this particular value. Okay, we have now none value. So if I want to drop it, I will say df1 dot drop na. So yes, this particular value was missing from this particular table. None means I have already told you that this particular value is missing. I have purposefully made this value missing. So if you want to drop the row containing that particular NA value, that is missing value, if you want to drop that particular row that contains a missing value, you can directly say df dot drop NA. So if you do not want to drop that particular row, so instead of drop NA, you can have some fill NA. So it will replace your NA value with the specified values. Okay. So let's say now we will have this, let's say 1, 2. Okay, this is my df1, 2 now. Okay, it is containing some value, missing value. So I will say df12 dot now fill na. In bracket I will say now unknown. Okay, so let's say how it is working. So yes, earlier here this particular value was missing. So now we have replaced this particular value with value of our choice. Okay, so you can replace any value using your fill in a method. Okay, either you can use drop na or you can use fill na. So drop na, what it does, it drops rows containing missing values, and fill na, it replaces the missing values with the specified numbers. Okay, so is na or is null, it detects the missing values in the data frame. For example, if you say df dot df 1 okay, here now we have two missing values. Okay, and if you want to check is there any missing values in your data set, so if we are going to say df dot df13 dot is na. Okay, so here you can say everything is false, but whenever there is a missing value it will say true. Okay, now apply, it applies the function along the axis of the frame. So apply means it can applies, it can apply a function along the rows or along the column. Okay, so depending on whatever your requirement is, you can do that. Same, we have seen the series duplicates, we have data frame duplicates. If you want to drop duplicate value, you have this drop duplicate functions. So it returns the duplicate value and data frame is given to you. Okay, you can also replace the old value with the new value, and this particular query we are going to see whenever we are going to see Boolean expression. Okay, so this was your data frame. So now first of all, now we are going to see data frame indexing. Now this indexing will be same as your NumPy indexing. NumPy indexing means whenever we were seeing 2D data, so same kind of thing we will be having here. Dot fill in I will say in Boston. Okay, so now this is my DF. Now we are going to say now indexing. So indexing. So first thing we are going to see is how to access a single column. Single column. Okay, so single column access, if you want to access a single column, you will write df in square brackets, you will write name. Okay, so this is how you can access a single column. Now I think there is one more thing. Okay, so this is how you can access a single column. So df dot I will say h. So yes, this is how you do it. So there is one more thing called as df dot columns. This is an attribute. So it will give you the name of the columns that are present in your data frame. Okay, name, age, city, these are the columns that are present in your data frame. So we have seen how to access a single column. Now if you want to access a column, you can access like this. Now we are going to say how to access rows. So if you want to access rows, you have two functions that are available, loc, dot loc and dot iloc. Okay, so let's say how we are going to use it. So df of loc, if I say now 2, okay, so let's say what it is going to give us. So 2 means it is giving us second row. So in the second row, name is Charlie, age is 35 and city is Chicago. Same way df dot loc of let's say 4. If I say now Emily 45 and city is none. Okay. So this is nothing but your loc function. So in loc function, you can have number of rows as well. So let's say 0 to, I will say 3. df of loc 0 to 3. So this will give us 0, 1, 2, 3. These records will be extracted. Okay. If I say 0 to 2, so these 3 records will be extracted. Here, just remember this particular number is also inclusive. This is not like indexing. Okay. Then let's see next how to access a single row and a column name. Okay, so here we can say df of loc, in bracket I want to have 1 comma, I will say I want to access age. So 1 comma I will say this is nothing but age. So 1 comma age, that means it should give me 30. Yes. So if you want to retrieve now Chicago, so what you will write? So you will write 2 comma city. Okay, 2 comma city. So df of loc in bracket 2 is the name of your row and name of your column is city. So here I will say city. So 2 comma city is nothing but your Chicago. Okay. Now I want to retrieve Bob. So Bob means name of the row is 1 and name of the column is name. So here we will say df of loc two comma name. So 2 comma name. So here, 1 comma name. So here we want to retrieve Bob. So we will say 1 comma name. So 1 comma name will be your Bob. Okay. So next thing we will see how to select number of rows and columns. So here I will say df dot loc. सबसे पहले we will see what is df. So this is our DF. Here now I want to see number of rows and number of columns. So I want to see now 0 to 2 number of rows. Okay. So here I will say DF of LOC in bracket. Now I want everything in this particular thing. Okay. So name each city. So first of all 0 to 2 I will say, and in bracket I will say column names. Now column names I want is name, age and city. So yes, 0, 1, 2, that is Alice, Bob, Charlie, and everything is extracted. Now I just want name and city column. So what I will do, DF of LOC, first I will say 0 colon 2, comma, age. Now what do we want? Name and city. So we will say name and city column, that only I want. So if we see it now, so this is how you can retrieve the values. This is how you can retrieve number of rows as well as number of columns. So this is how you can retrieve it using LOC. Now if you want to use ILOC. So ILOC is nothing but integer based location. ILOC means integer based location. Okay, here only integer values can be passed in the function. Whenever you are saying ILOC, within that only integer values can be passed. Okay, so we have rows and columns. We have two dimensions, right? So we have rows starting with 0 to some positive number, and we have columns also starting from 0 to some positive number. Okay, so your rows index starts with 0 and column index starts with 0 as well. Okay, so the example that we are saying right now has name, age and city. Okay, and we have 0, 1, 2, 3, 4. So these are nothing but your rows indexes. Okay, columns indexes will be, name will be having 0 index, 1 will be having ages and second will be your cities. Okay, so this is how you will retrieve the data. So 0 of 0 will retrieve this value, 1 of 1 will retrieve this value. So this is how you are going to retrieve the data. So here again we will say DF. So here I will say DF dot ILOC. I am saying now I want to retrieve 0th row and this LA that we are going to know. So 0th row and this New York. So New York in 0, 1, 2, right? What is the New York? Where is New York? New York belongs to city column. So city columns index is 2. So 0, 2. So that is nothing but your New York. Okay. Do you understand how it is working? We will see one more thing, df.iloc. Now let's say I want to extract this 40. So first of all, it is in the third row and in the age column. So age column is at, what is the ages index? 1. So what we want is 3, 1. So df of ILOC 3, 1. Okay, correct, 3, 1, we have 40. Okay, same way you can do it with the number of rows and number of columns. So number of rows now I want to retrieve from 0 to 2. df dot ILOC. I'm just retrieving now rows 0 to 2. So 0 to 2 ILOC means it is going to retrieve only two values, Alice and Bob. Okay, start and stop, inclusive and exclusive. Okay, now df dot ILOC, I will say 0 to 2, 0 to 2. Okay, and I want columns starting from 1, that is age and city only I want. So I will say 1, 2, it should go to the last. So yes, it is 0 and 1 we have selecting, because this is for rows and this is for columns. So columns are starting from 1. So this was 0th column, this was first column, so age and city, and 1 colon I have not given the end, so it will go by default, will go to the end only. Okay, so here I will write it for your reference, df dot ILOC, here start, stop, step. Wait. Okay, comma, here start, stop and step. This is for rows, this will be for your columns. Okay, rows by default 0 to some positive number, columns also 0 to some positive number, since we are dealing with ILOC. Okay, since we are dealing with ILOC. Start by default, it will start with 0 if you do not give anything, any number. Stop, here this particular thing is inclusive, stop is exclusive, and step is by default 1. Here inclusive, again exclusive, and this is by default 1. Okay, so this is how your ILOC will work. So please go through this particular slide. Whatever we have seen just right now with the example, same thing is described on this particular slide. The same thing is described in this particular slide also. So let's say now data frame built-in functions. So there are some more built-in functions that are used very frequently with So let's see what are those. Okay. So now df dot first function that we are going to see is df dot info. So df dot info means it provides you the concise summary, including your what are the data types, how many null counts are there, memory usage of your data frame, everything that will be provided, everything that is available with your data frame, that will be provided with df.info. So df.info, so just read it. Now 5 entries 0 to 4 is your range index, correct? 5 entries 0 to 4. Then data columns, we have total 3 columns, yes. Then columns now. Now these are the indexes of the columns 0, 1. This is just a reference. So we have now column. So name, we have 5 non-null values. Okay. Then age, we have 5 non-null values. But city has 4 non-null values. That means by looking at this particular information, you can see that one value is missing. That is, we have one missing value in the data frame. So by looking at data frame, you can also tell or your data frame, if your data frame contains millions of records, so at that particular point of time, you cannot view every record line by line. So instead of that, you can do this if you want to see how many null values are there in your data set, df.info. So here you can calculate how many values are missing. Okay, so next thing is df.describe. So describe gives you the statistical for numerical columns. Now this is very important. This describe function will be effective in case of numerical columns only. So here now we were saying our data frame was df. So we have exactly one numerical column. So if I say df.describe, so yes, so we have one numerical column age. So our count is 5, our mean for that particular column is 35, standard deviation is 7.90. Minimum value from that particular age is 25, maximum value from that particular age is 45, and this is 25 percentile. This is not percentage, these are percentile. So 25 percentile value is 30, 50 percentile value is 35, and 75 percentile value is 40. So this is nothing but this is how your describe function works. It only works on numerical columns. Then we have head and tail. So head returns the first n rows from data frame. Tail returns the last n rows from your data frame. Okay. So here if I say df.head, I will say 2. So it will return the first 2 lines from your data frame. So these are the first 2 lines from your data frame. I will say df dot, I want to now see what are the last 2 lines from your data frame. So I will say df dot tell 2. So these are your last 2 data frame. So by default, if you say df dot head, so it will by default print first 5 entries from your data frame. Okay, in this case our entire data frame. Okay, same way will go for the tail as well. If you do not consider any particular value, it will print first 5 and last 5 record according to the what function that you have provided. Now let's see reading data with pandas. Now there are multiple types of files that are available with us. We have CSV file, we have XN file, we have JSON files, HTML file, SQL file, HDF file. So if you want to read say CSV file, so we have function called read CSV. So whatever that you have written in your CSV file, it will be converted into your data frame. Same if you have an Excel file, so you can convert your Excel files data into the data frame. So data frame means you can have all of these operations we have been seeing until now, you can perform on that particular data frame. Then JSON format is also same with the JSON, HTML, SQL and HDF file. Okay, so if you want to import, if you want to read any CSV file, so what is the syntax? So pd dot read CSV. So in the bracket you will say the name of your file. So if your file is currently working, currently resides in your working directory, then you can directly give this particular data.csv. Okay, if your file is not in a working directory, current working directory, so in that case you have to give the full path of the file. Okay, and then you can say df.head. So df.head means it will give you the first 5 elements of the Excel file or CSV file. Now there are CSV file means comma separated file. There is also called as a TSV file. So TSV files is nothing but the tab separated file. So how can you read the tab separated file? So in order to read the tab separated file, you can use the same function as pd.readcsv. So in a separator, you can say instead of now in CSV file, the separator will be comma, but this is now we are dealing with the TSV file, that is your separated separator will be /t. Okay, so instead of comma you will have the /t, and then you can convert it into the data frame. So instead of CSV file, if you have TSV file, you can do something like this. You can also pass file path or URL of the data file as an argument. So if you have a data set somewhere, so you can directly give the file path of that particular data set, or you can, if you have the data somewhere in your drive, so you can give the URL of that particular location. Okay, if so, next part that we have already seen, how to select columns, how to select rows. So LOC, dot LOC and dot ILOC, so these things that we have already seen. Now there is one more thing that you can do is, you can select the rows based on the condition, okay, or you can use the Boolean indexing, or we can say query method. Okay, so सबसे पहले we are going to see with the Boolean indexing, and then we will see with the query method. Now this is nothing but your data frame. So in this particular data frame, let's say I want to select only those rows in which age is greater than 30. Okay, so my condition is age is greater than 30. So here now, if we directly apply on your data frame, so let's say what we are getting. Sorry, greater than 30. So yes, so what it is giving us, so it is giving us the correct result. That is, it is giving us the results where this particular value is false, this particular value is false. These are true values, but I do not want only Boolean result, I want the actual result. So what we will do is, we will apply this particular result on the data frame. So whenever I am doing that, so yes, now I am getting the only true values. So whenever you want to retrieve the Boolean indexing of this particular, or if you want to retrieve data based on the condition, so you have to write the condition and apply it on the data frame again. Okay, so this is how you can do it. So this is how you can use the Boolean indexing. So one more thing that you can do is, you can do the same thing with the help of query function. Okay, so here you can say df.query, my query is I want to rows where age is greater than 30. So you will write something like this. Okay, so let's say data equal to df dot query, in bracket I will say age greater than 30. Now same query we are converting into the, we are doing it using query function. So here we will say filter data. Okay, so let's say what result we are getting. So here I think we have to write something like this, age greater than 30. So yes, you have to write the entire function, entire thing in the single brackets, single quotes. So whenever you write like this, we are getting the same result as this particular thing. Okay, so this is how your condition thing works. If you do not want to directly write the conditions, you can pass it in the query function as well. Okay, this was your data selection as well as filtering. So filtering means we were selecting the data based on some kind of condition. Okay, so along with this relational operator, you can also use logical operators. Okay, so logical operator means and, or, not. These operator and combination of these can be used in order to filter the data. So filtering data means you have a specific condition with you, and depending on the specific condition you want to retrieve the data. Now the next part is sort. Sort means, as the name suggests, you are going to sort the data in the ascending order or descending order. So let's say add now df. डेटामध्ये सर्व काय करायचं होतं. I will say this is my data, this is my 14 number of, and then this is, I will say Houston, this is, I will say Boston. But here I will say my last thing is 60. Okay, so this is the thing that I want to, this is the data frame I am going to use DA for 40. So first thing is we can sort data frame by the values of one or more columns. Now if we are going to sort that particular thing, we are going to use numerical columns. Okay, so for this particular example we are going to use the numerical columns. So I will say df dot sort values by age. Okay, so here I will say df of 14 dot sort values by is equal to, this is nothing but your age. Okay, here now 60, wait, I will say here my DF of 14 is 41, 30, 35, 40 and 60. So let's say if I sort it by age, so what it will come. So it is now coming 30, 35, 40, then 41 and 60. So entire rows are rearranged according to the age. So this is how you can use sort values. Now you can also sort by index labels. So currently your, I will say C. Print, I will say C. So if I want to now see C dot sort index. First we will see type of C. Yeah. Okay, type of C is data frame only. So C dot, now we are going to sort the indexes. Sort index. Okay, here now indexes are 1, 2, 3, 0, 4. So we are going to use the same C and we are going to sort the index. Sort the index wise. So yes, now it is sorted. Okay, this was your C and now we are sorting index wise 0, 1, 2, 3, 4. Yes. So this is your sort index. So whatever index that you are providing, you can also provide sort it index wise. Then next thing is df of n largest. So n largest is you can return the n largest elements from the data based on specified columns. So for example, I want 2 largest numbers from the age column and 2 smallest number from the age column. So how we are going to see is, we will say df dot n largest. We want to retrieve three largest values from each column. Okay, so here we'll say df of 14. So here df 14 dot n largest, where n is equal to, I will say 3, and column equal to h. So three largest values. Three largest values means we are getting 60, 40 and 41. Yes, we are getting the correct values. Same if will be applied for the n smallest, that we want to retrieve three smallest values. So n equal to 3, comma, columns equal to h. Okay, now smallest means I think it will be 30, 35, 40. So 30 means Bob, 40 is David and Alice. So 30, 35, 40, 30, 35, 40, not 41, 40 is there. So 30, 35, 40 means Bob, Charlie and David will be returned. Now, if you do not want the result in the ascending order, then you can say df of the 14 sort values by, I will say, h and ascending equal to, I will say, false. So if I say by default it is getting in the ascending order, here I will say if you sort it like this, it is going in the ascending order. But if I do not want in ascending order, you can just say ascending equal to false. So it will sort the entire data frame in a descending order. To false. Okay, now false means this was in ascending order 30, 35, 40, 41, 60. This is your descending order 60, 41, 40, 35 and 30.
Okay, so next important part involves grouping and aggregation of the data. So the grouping is very essential in case of Pandas. So whenever you do grouping and aggregation, you get a very powerful insight about your data. Okay, in order to draw various conclusions, you have to perform grouping along with aggregation. Now, first of all, we will see what involves in grouping. So grouping involves, first of all, splitting data into groups. As the name suggests, your grouping involves splitting data on the basis of groups. So on the basis of one or more categorical variables, you can split it. Okay, so it is typically, this is nothing but grouping. So after the grouping, there are some aggregation operation that you can perform on this grouping to summarize the data of each group. Okay, so in order to do this particular thing, you have to use a Pandas method called as group by. Okay, specifying one or more columns to for the group by. So aggregation functions. So aggregation function is nothing but you can say they are summary functions, or it gives you summary statistics or metrics for each group. So what are your common aggregation functions? So common aggregation functions are sum, mean, median, count, mean, max, and you can also write your own custom functions. Okay, so aggregation results in a completely new data frame where each row and each column represents the aggregated value. Okay, so first of all, what we are doing, we are taking our data set, we are splitting into the groups, and on the group we are using aggregation function. So each row and each column represents your aggregated data in the returned data frame. Okay, so let's see how it is going. So we are going to use this particular data for our group by. Okay, so first of all, we will see what is happening. So this is my data frame. Okay, so in this particular data frame, my problem statement is I have to group by city and calculate the mean age. So my problem statement is I have to calculate mean age city wise. I have to calculate mean age, average age city wise. So in order to do that, so I have to first group by the data city wise. Okay. So here our problem is calculate mean age city wise. This is my problem statement. So I have to calculate the mean age city wise. So city wise means first of all our data set will be grouped city wise. Okay, and on this particular data you will apply the aggregate function. Now aggregate function. So aggregate function, for that you have to calculate mean age. So mean is the aggregate function that we are talking about. So you go like this, data set grouping city wise, and then on that you will apply the aggregate function. So here you can see df dot group by city, and this is age. First of all, your entire data set will be grouped city wise. Then your we have to calculate mean age. Okay, so we have to consider the column age, and aggregation function is mean. So this is how you can write the function group by. Okay, let's see it with our. So I will say grouped data equal to df 14 dot group by bracket. Now we have to group by first of all city wise, and then I want age, and on that we are applying aggregate function. So aggregate function will be applied on this age column. So we will say print grouped data. Okay, so this is your Boston's average is 60, Houston's average is now Houston's average is 40, Chicago's average is 35, LA's average is 30, New York's average is 41. Our values are coming as it is because we do not have the redundant values. If you have the redundant values, you can see the difference in the output. Okay, so let's say here if we want to see the difference, let's say control V, name age city New York, LA. Let's say again here LA, here you will say again New York. Okay, so here I will say this is TF15, here it is TF4. Okay, so now we have 2 LA and 2 New York. Now if we apply the same query that I want to see group data, I want to calculate city wise mean age. Okay, so group data is equal to df15 dot group by, here we will say city, then dot, then I will say age, and here I will say name. So let's run this. Yes, here if I say group data, so yeah, now the average will be changed. Boston's average is 60 because we have one Boston. Now New York and LA. So New York's average is now 40.5. So New York we have two values. So 40 plus 41 divided by 2. So that will be your New York's average, and LA's average will be 30 plus 35 divided by 2. That is 32.5. This will be your LA's average. So this is how your group by function works. So this is your average age city wise. Okay. So next important part we are going to see is merging and joining of the data. So in that first function where we are going to see pd.concat. So pd.concat function. So what it does? So concat function as the name suggests, it concatenates data frames along either rows or columns. Okay. So if you want to concatenate along rows, then you have to provide axis is equal to 0. When you mention axis equal to 0, that means concatenation will be done row wise. When you provide axis is equal to 1, that means your concatenation will be done column wise. Okay, so let's see it with example now. So for example, we are going to get this particular data frame. Okay, so df.to1, this is my first data frame, and df dot, this is my second data frame. Okay, so first data frame contains id and name. Id is 1 2 3, names are Alice, Bob and Charlie. Id is second data frame, id is 2 3 4, and age is 25 30 45. So if I want to say pd dot now concat, if I say row wise, so row wise means these rows and these rows will be concatenated. Okay, concat in bracket, I will say df21 comma df22 comma axis. Now first of all we will see 0, that is row wise concatenation. What is the result? So yes, this is how it is row wise concatenated. id, name and age, 3 columns are made. 1 2, 1 is Alice, 1 Alice. So in the second here age is not there, so name is good. Then second Bob, age is not there. Third Charlie, age is not there. Then this is your row wise concatenation. So first, this is your first data frame and this is your second data frame. So they are concatenated row wise. If you want to change the concatenation to column wise, so see df21 comma df22 comma axis equal to 1. Now if I say, now this is axis equal to 1, that means column wise concatenation. So id, name and age will be there. So let's say how it is concatenated. So id, name, age and the values are inserted accordingly. Correct? id, name and age. id is Alice, Bob and Charlie, and this is id, age. So this is your first string and this is your second string. Yes, so these they are concatenated accordingly. What is going on essentially in the concatenation is it is only concatenated along the given axis. The values are merely concatenated along the given axis. They are not replaced, they are not, any operation is not done, they are just simply concatenated along the row wise or along the column wise. Axis 0 means it will be row, row wise concatenation means this is your first data frame and this is your second data frame, and axis 1 means it will be column wise. So this is your first data frame and this is your second data frame. Okay, so this is how your result looks. Now next part is, let's see now next part. Next part is nothing but joins. Now there are four types of joins. In four ways you can join the data. You can join inner join, you can have inner join, you can have left join, you can have right join, you can have outer join. So first of all we will see with example, we will see with diagrams what are these joins. So first of all we have inner join. So inner join means first of all we will need two data frames. So let's say my first data frame is df21 and my second data frame is df22. Okay, whenever I say inner join, that means the common elements from both data frames will be retrieved. Okay, so these elements will be retrieved. Whenever I say left join, so left join means this is my df21, this is my df22. So left join means all the elements from the left data frame along with the common elements from right data frame. All the elements from the left data frame will be there along with the common elements from left and right. Just as we seen, the vice versa will be your right join. Instead of data from left, we will consider the data from right and common elements from right and left. Here I will say this. Please pardon my drawing. My drawing is not that good. I'm trying to draw a circle. Okay, so this is your df of 21, this is of df of 22. So this is a right join. So right means the right data sets, elements from the right data set, all the elements from the right data sets as well as common elements from right and left data sets will be considered. And whenever I say outer join, so outer join means all elements from left as well as right will be considered. Okay, so all the elements from left as well as right will be considered for the joining. So please remember these diagrams while you are performing the operations on join. Okay, so now we are going to use this data for merging. Okay, so let's say what is df of 21. So df of 21 contains id 123 and name Alice Bob Charlie, and this is my df2 comma, I will say this is your df22, that is id and age, that is 234 and 25 30 45. Now if I say inner join, okay, so inner join means only elements that are common from frame 1 and frame 2 will be extracted. So what are the common elements? You can say on the basis of, if I say id, I am going to join them. So 2 3 here is there and 2 3 also are here. Okay, join will also be done on the basis of your column. So pd dot, I will say join, I will say now df of 21 comma df of 22 comma, I will say on, now on the basis of which column. So on the basis of I need id and how is I want inner join. Okay, so if I run this, so let's see what is example. What is the answer that we are getting? Sorry, pd dot. The operation that we are going to see is the operation that helps you with this join is pd dot merge operation. So in the merge operation, what you will pass? You will pass first data frame, second data frame, on the basis of which column that you want to join them and how, means you want left, inner, right or outer. Okay, so let's see it with this. So pd dot merge. I will say df21, df22 on id and how is inner. So yes, here I have said on the basis of id and inner. Inner means it will consider common elements. So common elements are 2, 3 and 2, 3. So 2, 3 is Bob, Charlie and their ages are 25, 30. So this is the data frame that is returned. Okay. Now if I say pd dot, again now we will say df21 comma df. Recording start के लिए कमी.
So df of, so next thing that we are going to see is left join. Okay, so pd dot merge, I will say df of 21 comma df of 22 comma on is equal to id and how is left. So in the left, what is happening? Left join, it is happening is all the elements from left will be considered and elements that are common to left and right. So let's say how is this working. So 2, 3, all the elements from left and common elements from left and right. So 1, 2, 3 are considered, but once age is not there, so that's why it has missing value. Okay, same thing that we are going to see it with now df. Now next thing is pd dot merge in bracket df of 21 comma df of 22 comma on is equal to id comma how is equal to, now we are going to see right join. So right means we are going to consider all the elements from right data frame and common elements from right and left. So let's say how it is going. So here your right element, right frame is now 2, 3, 4. So 2, 3, 4 will be there and their ages will be there. Since 4 does not have a name, it will be a name. Okay, so all the elements from right will be considered and the elements from left, common elements from left and right. Okay, the last thing is pd dot merge df of 21 comma df of 22 comma on we are saying id and how is we are saying now outer. Okay, so let's say outer join means everything we are going to consider. So this is nothing but your outer join. All the elements from right as well as left are considered. So this is your outer join. This is how your outer join looks. So thank you so much guys for your patience.